Yeah, we have two developers working side by side. The first one is Claude, whatever the newest model, and the ChatGPT 01. And Claude didn't finish the code. It timed me out. It says Claude response was limited as it hit the maximum length allowed at this time. Well, okay, yeah, fair enough. I mean, it's 485 lines of code, but then GPT-01 is able to generate the whole code. So Claudette, keep it up. And this is what we have at the moment. It's an EMG and simulation tool. Those meant to be fingers. They look like sausages. Well, I mean, fingers do look like sausages. I mean, yeah, this is a hand. And this is a demo in the beginning where I'm not moving it, but you can move each finger yourself if you like, and it will show EMG recorded from these two electrodes positioned on the wrist. Yeah, and we have two versions now. Which one do you like better? Well, ideally there will be an option to split the two signals into red and blue, left and right. So this is the baseline. It does some baseline noise. You can move each finger. So the difference between the pinky get more blue artifact than red, and if you move the index finger you have more red than the blue. So that's pretty much all it does. We'll keep it pretty basic. Yeah, I'm not sure entirely how to use Claude. It keeps timing out. Maybe once we split the code, Claude would be able to be useful again. Yeah, so ChatGPT, the 01 reasoning model was thinking for 8 seconds, apparently meant to be PhD level. Code separation, ensuring responsive design, mapping the approach. Yes, it meant to generate 3 separate files, crafting the layout, minimal white space around the hand. Yeah, that would especially be useful on wider screens. Okay, did it actually generate the whole thing? That's JavaScript, CSS, HTML. Okay, so start with the HTML. So now it's only 100 lines of code, and it should be calling, yeah, on wider screens. It does adjust pretty well, but yeah, there's a room for improvement. Have it running. We have the instructions, theory, future directions. Perfect. Okay, it's working really well now, but there is one
You're
problem.
welcome. Let me know if anything else needs tweaking.
Yeah, there's one problem where when changing from to a wider window, the signals are not actually running.
This happens because when switching layouts, the JavaScript managing the signals, whether merged or split, doesn't properly reinitialize for the new layout. We can fix this by adding a resize event listener to detect screen changes and reinitialize the EMG waveforms. Here's the fix.
Okay, now it's working. Yep, very nice. Thank you very much. Yes, so this demo is not great. You can keep flexing the pinky and the index finger to see the difference. We did it ourselves. we didn't need the robot to modify the code, so maybe, yeah, no, we still need robots. Yeah, the demo is still running, so you can see them horizontally or side by side. They're stacked up. That's very, very, very nice.
It looks like the layout is transitioning nicely between the stacked and side-by-side configurations. On the wide screen, the hand image is placed on the left, and the two waveform charts are displayed on the right, arranged vertically. The electrode indicators are clearly visible, and the charts look crisp against the light background grid. The smoothness of the line drawing suggests the signals are being updated properly. From a visual standpoint, the design strikes a good balance between clarity and simplicity. The spacing seems comfortable, with enough room to appreciate both the hand diagram and the signal charts without feeling cluttered. One possible critique is that the labels, particularly the E1 and E2 inside the wrist area, may be a bit small and could blend slightly into the background. Ensuring that their text contrasts more sharply with the skin tone or providing a subtle outline could improve readability. Another consideration might be adding a very slight padding or a distinct border around the charts to set them apart visually when the page is viewed in bright conditions or on a screen with lower contrast. Overall, this is a very effective demonstration tool. It is intuitive, pleasing to the eye, and seems quite stable now. The concept of switching from a single combined waveform to two separate charts depending on screen width is a clever, adaptive design choice. With a little more polish on labels and perhaps some fine-tuning of spacing, this can easily stand as a polished educational resource for people interested in EMG signals. How the tool works. This tool simulates the electrical muscle activity recorded by electrodes placed near muscles controlling hand movement. On narrower screens, it displays the hand above a single combined chart containing both electrode signals to conserve space and maintain a single screen experience. On wider screens, it adapts by placing the hand diagram on the left and two separate electrode charts stacked vertically on the right, providing a more detailed view and reducing empty space around the hand. Clicking a finger triggers a brief change in its position and a corresponding increase in the recorded signals, illustrating the connection between muscle movements and electrical activity. Theory behind it. The concept behind this simulation is rooted in electromyograms, EMGs, which capture the electrical signals produced by muscles as they contract. Although this demonstration does not represent actual medical data, it provides an intuitive, accessible introduction to the principles behind EMG recordings. In real-world biomedical research, EMG signals can be used to investigate neuromuscular function, guide physical rehabilitation strategies, control prosthetic devices, and even develop new interfaces for interacting with technology. Future directions. Looking ahead, this tool may incorporate a wider range of biomedical signals, such as electroencephalograms, EEGs, and electrocardiograms, ECGs, expanding its educational potential. The goal is to continue refining the interface so it remains simple, accessible, and fully contained in a single screen, all without relying on proprietary or closed-source platforms. You can follow the ongoing development and experimentation on the Bionic House YouTube channel and on the website, where feedback is always welcome. Support through Patreon would help enhance the range of features, improve visualizations, and keep the project free and open source.
Specific questions about any of the tools currently available on the website, do let me know. Yeah, for this one, for example, I was thinking it's better to generate the more useful knowledge graph diagrams as opposed to those silly images that ChatGPT generates. Some of them are better than others, but generally, yeah, not so great. So let me know what you think. Yeah, on the EMG, they're just using your mouse to generate to mock up. Yeah, it's called MyoMock, and yeah, this is just moving the mouse. Also should work on touchscreen as well. You might need a hearing test after listening to this music, which luckily we also have on the website. This is what's mine doing at the moment.